physical science. I feel like I say that a lot.
Yeah.
Next semester it won't be much review. Okay. Yeah, your four major types of chemical reactions. You're going to need to be able to distinguish them or identify what type of chemical reaction they are based on the format that they have. Again, I'm one of those things where I don't think it's overly complicated. Okay? First type is a synthesis reaction. To synthesize means to combine. Okay? So what do you think a synthesis reaction structure is going to look like?
A plus B equals AB.
Okay. Yes, but like explain that, like what's happening
They're
there.
being put together.
Yeah, they're being put together. Okay? Now, does it always have to be two reactants, one product?
No.
Could it be three reactants, one product?
No.
Could it be three reactants and technically two products?
No. Yeah.
It's still combining in some
That's not a
sort.
single product though.
Oh, okay. Yep, looks like it has to be a single product.
I forgot your own notes.
I couldn't think of a time where three turned into two, but I just wasn't 100% sure. Okay, so here we go. Here's kind of the general idea here. Synthesis reactions, you will always have more what than what?
Products and
Reactants than
reactants.
products.
Or reactants.
Or they use me as a blanket.
Wow. Okay, so more reactants than products. Now, it appears that it has to be a single product, but, okay? But that makes sense because we're doing what? Combining. Okay? Sometimes they call it combination. You might see that in your notes, or not in your notes, in your textbook reading. You might see combination reaction. I think this is a bullet. That's not a negative A. Just saying. Okay, so here's an actual example of what it would look like. Calcium plus chlorine gas comes to produce that ionic solid. Combining or synthesis. Okay, another example. H2O and CaO forming calcium hydroxide. Again, combining. Alright, second type is decomposition. You guys probably know what decompose means. What does decompose mean? To
Break
rot.
apart.
To break
Okay.
down.
To break down, and in the context of this, it's really to break apart, but you could say this is breaking down as well. It's when reactants break down into more or simpler products. Now, it says this usually requires an input of energy. Why would it usually require an input of energy?
Because it takes more strength to take two magnets apart.
If you're breaking things down, it's going to require a little bit of energy. Okay, now, not always, but usually. Okay, is there any relationship between decomposition reaction and synthesis reaction? They're like, yeah.
Kind of the exact.
Why don't they store things in vacuums? Because then would it not decompose? Is that why you vacuum seal stuff?
Yeah.
Why don't they just do like store meat and stuff and just say use vacuum?
They
Vacuum
do.
seal.
Vacuum sealing. Not like that, but
Why
like
would you
just
put
like,
it in a big, like that's.
Why would you put it in a constantly sucking vacuum?
Why would you have this huge building with vacuum that you couldn't go in versus just put it in a plastic?
Let's store it, it'll stay fresh forever.
I feel like
Yeah,
there's
but you can't ever get it.
It'll stay fresh forever, but we can never get it.
It'll taunt us
Ah,
for the rest of our days.
like those, like
Man,
those
that steak was really good in that window.
Like those advertise those like KitchenAid things, like you put it in the bag, the
Yeah, I
open top
know.
bag, and it goes, and then sucks
I feel
on
like
the
there's
air.
things.
Hey, can you do that sound effect one more time?
I don't think I can, because actually.
Okay, so the key here is these are, that'll help distinguish. So if I say that in a
You are
simple,
not amused.
Oh, Natalie.
okay, so if they're opposites, then what could you say about for decomposition? What is more than what?
More products than reactants.
Okay, more products than reactants. Okay, does that mean like I created matter?
Yes. No. It means
No, you just-
matter.
No. So here's the thing here. I have more pieces, but this is still going to be the same stuff, right? It's like taking a sandwich would be one sandwich and breaking it up and taking it apart into its various pieces. That make sense? Okay, that's a really important concept when we get into next chapter. We'll talk about the bowl, which that's my favorite chapter. Yes, I love the sandwich chapter. My favorite.
What?
We get to eat sandwiches all day.
Did
Okay.
we call it that?
All right. So there's a. I'm joking. Here we go. HGO breaking down into mercury and diatomic oxygen would be an example of a decomposition reaction. There's quite a few of them. Okay. Single replacement. Ah, the single replacement.
Oh yeah. We didn't do this.
Okay. All right. Let's think of a hypothetical situation. All right.
That thing right there, the ball,
The ball right there.
ball thing.
The ball
Ball
thing.
thing.
That's the polygrove.
So single replacement reaction. Here's kind of what happens. Let me give you a theoretical example of this. Let's say gauge.
No, the ball thing, look, like that.
How's that a single replacement reaction?
It's a single replacement reaction.
The one on one side replaces the
Kind
other.
of. This is a better example. Let's say gauge goes to a non-Grandview approved dance
Okay.
with
I'll
a
go with that.
significant other.
Jacket.
I'm not saying names or anything. Just gauge goes.
I don't like where this is going. I don't like it.
Gauge goes to this non-Grandview or Mr. Kramer or parent-approved dance.
And then I leave, and Marty comes.
Marty comes and snatches the
No,
girl
I left
away
already.
from Gage, replaces Gage, and snatches.
Actually, that'd be a double replacement.
No.
No,
Yeah, but with
No.
Marty's
Oh, I
guy with
should've used
Brianna.
That's it.
That's a
Marty's
double
thing.
replacement.
Okay. Okay, we gotta think of somebody that's single. Brevin. So Brevin comes in with his dashing good looks.
Oh yeah.
And the lady that originally thought Gage was this hunk of a man was like, oh, Brevin, that's a little bit more hunky. And so what what ends up happening is Brevin comes in and takes Gage and says, you go home. And so now in the end, Gage is probably better off. But okay, so Gage ends up being single and alone. Okay, and Brevin is all hunky dory because he's got a significant other.
For about 2 weeks.
For
Yikes.
about 2 weeks until they realize Brevin's is bad. Okay. So here's the thing. Now I realize it's kind of silly, but it kind of helps us understand that what happens here is you have some element that is by themselves come in and replace an element and kick that other element that was bonded to really be by itself on the product side. Okay? Now, the question you might be asking is why would this happen? And it has everything to do with the fact that A is more reactive than B, and so it's more stable for A to be bonded than for B to be bonded.
Or A is more attractive
Uh-huh.
than B.
Yeah. If we're talking
That's-
real life situations.
But like bonding, like more attractive.
Yeah.
Okay, I understood that one.
Or like,
A and D had better chemistry.
or B was smooth, but A was rich and smooth.
That's funny.
So here's an example here. Now notice, I want to be very careful when I'm talking about this. Well, A and B, they're both cations, or they're both gonna have properties of cations. Or you could say, like, so what I'm saying is a cation cannot replace an anion. That's a no.
Oh, okay, yeah.
Okay? So if you look here, we have a metal which can very much act like a cation if it wanted to, come in and replace copper. Now the thing here, the giveaway here that this is single replacement, is you have a single guy on both the reactant and the product sides, and the single guy at the beginning replaces the single guy and replaces the guy that was bonded in the beginning. Okay, everybody see it? Questions? Brevin? You happy now?
Good.
For 2 weeks? Okay, double replacement. Now this might be a little better for Gage and Marty.
No.
Oh,
How about we each start with the other ones and then get to
Yeah,
this?
start with
There we
Alright. Yeah, let's do, yeah, we'll say. We'll say Marty goes to, I don't know,
Some random name.
the Dixie Stampede.
Trinity likes Noah, just them.
I don't like no. I keep trying things. I don't like Noah.
Noah?
She does.
Marty, I hate just literally just saying this because you know that this lecture.
Okay, so here's the thing.
Whoa.
We got two couples. We have two erratic couples that are just like typical high schoolers. They just want to be in a relationship. They don't really care about the other person.
This is gonna be.
And there's no purpose or direction of the relationship. They just want to have a fun old time. They're not actually trying to get married or anything that real relationships are all about. Okay, anyways. That's my passive aggressive dating advice for you guys. Trinity,
What?
I'm giving passive aggressive dating
Now we're
advice.
talking about dating too, so.
Oh.
What?
You're spicy. Holy crap.
Okay, here's what happens. Notice how A and B flip partners. A was once with Y, and now A is with Z. Cations and anions flip their partners. So the biggest giveaway to know this is a double replacement reaction is if you have no loner, right? First off, you have no single guy. And if you looked up here, you would see that your anions and your cations flip who they were with. Okay? Here, lead was with nitrate, now lead is with chromate, and potassium's with the nitrate. Alright, then we've got these last three, which are going to be a little bit goofy, so you're going to want to pay very close attention and follow along with this. I'm going to start with the double replacement that I had up there, which was, so write this in somewhere.
It's already in
Is it for you?
That they pointed that out, Natalie.
there. Is she was studying today for high school? For what? I don't know. She's studying for someone.
Something for Mrs. Lynn.
Who?
Oh yeah, yeah.
Mrs.
My mom was like,
McGuess,
she was
Bella's
studying
mom.
today for second grade. I was like, I'm pretty sure.
She's been doing a lot of stuff. She's done for me.
We've had a ton of teachers gone.
Yeah, she did
Remember?
one day. Yeah, she was like, I should just come to Grandview and get her full-time teacher.
I would
Wow.
actually love that.
There's a lot of death going around.
What? There's a lot of what?
I like the phrasing of that.
I know.
Okay. So, we have, well, first of all, is this a synthesis, single, double, composition, what is it?
Double.
Okay, double replacement, okay. Now I'm gonna write the ionic equation, the spectator ions, and the net ionic. So here is what the ionic equation is going to look like. First off, what does aqueous mean?
Dissolve.
Dissolved in water. Well, you guys may or may not know this, but when you take an ionic compound and you dissolve it in water, it breaks up into its ions and water surrounds it. Okay? So what we're going to have to do is we're going to have to take anything that is aqueous and we're going to have to break it up into its individual ions. Okay? We have a cation and an anion. Right? There's a cation and an anion there. What is my cation? Lead, okay? We have to identify how many leads we have along with its charge. How many leads do we have? One, okay. How much charge is it going to have? And how would you figure it out?
You would plus everybody.
Plus 2.
Yeah,
Plus 2. How did you
No.
know that?
Oh, yes, it is.
yeah, plus 2, because of crisscross.
Okay? There's a couple ways. If you can look at the periodic table and figure it out, do it. But lead is not one of those guys you can look at the periodic table and figure it out. So you'd have to take and uncrisscross the charge and find that it is 2 plus. Okay? Then we have my nitrates. First thing you want to identify is how many nitrates you have. How many do you have? 2.
6, so
Now I'm going to put it as a coefficient because I have 2 of them. Because it's not bonded anymore. What is the charge of nitrate? You all should know this.
Negative.
2 minus.
That would be so.
Okay, first off, first one's always positive, second's always negative. Second of all, you should know the charge of nitrate. Third of all, you can uncrisscross to figure it out.
Well, wait. What if nitrate was negative 2? Then how would you figure it out?
Then you'd have to know what the other one is.
Well, then you would uncrisscross and then you would say 2, but it's actually 4. So I don't know.
Yeah, but we know what nitrate is, so, yeah, you're talking about if it reduced down and it was 1 and 1 or something like that, or, yeah. But we know nitrate's -1, so we know that's not the case. Okay? Plus, moving on to the next one. What's the cation?
Potassium.
Potassium. How many of them do we have?
Dos.
So notice I didn't write it as a subscript. The only subscripts you're going to have for ions are your polyatomic ions are going to stay in a group. Okay, what's the charge of potassium? There's 2 ways to figure it out. Look at the periodic table. Look at the periodic table since it's one of those ones that's common, or uncrisscross. But be careful, you won't want to uncrisscross the 4 because how many chromates do I have?
1.
1. Okay? And I just stated that we have 1 chromate, so I do not have to put a coefficient. And what is the charge?
Negative.
Oh,
2.
negative 2. Again, uncrisscross charge. Or, in this case, polyatomic ion have memorized. Boy, man, that memorizing. I should probably put aqueous in here.
I'm going to do the Lewis structures.
Okay? Now, what do I do with this guy? The answer is nothing. It's not dissolved. So I'm just going to leave it as a solid, because it doesn't say aqueous, does it?
No, that's why.
Don't touch it. It's not in ion form. It's not aqueous. So leave it in its solidified form. All I've done here is taken the aqueous and broken them down into their ions by finding out how many ions you have, by looking at subscripts and coefficients, and by uncrisscrossing to find charges. That's it. Now this is a little goofier because I don't have a subscript here, but I do have 2 KNO3s. So how many potassiums am I going to have? We already know the charge of potassium, right? I don't have to rethink about that. We already figured it out over here. Do I have to rethink about the charge of nitrate? I also have 2 of that
Why
because
is
of because I only have 1 NO3 and 1 KNO3, but I have 2 of the whole thing.
Oh, I see.
Okay? So this right here, and you're going to have to do this in your homework, is your ionic equation.
That is.
Right there.
Can I take a picture of that? Why are you writing your?
Sure. I hope you write it in your notes, but
I was just watching.
okay? That's the hardest of the three here. Spectator ions. What a spectator ion is, what do spectators do?
Watch.
They watch. Do they do anything?
No.
No, they just watch, okay? So it's essentially that. A spectator ion is an ion that doesn't do anything or stays unchanged from the beginning to the end. Are there any spectator ions? Don't leave. We still got about a minute and a half yet. Is there anything that stays the same on the reactant side as on the product side?
Yeah, the PbCrO4. Oh, just kidding.
No.
Not on this one.
Oh no. Yeah, two. Yeah.
Okay. What
Oh.
about 2NO?
Those are your two spectator ions, because are they involved in any reaction?
Not really.
No, they stayed as the same form in the beginning and the end. They didn't change their form, so did they react?
No.
Did they? No, okay? Last thing, net ionic equation is just canceling out your spectator ions because they're not involved in anything, and it's what's left, or your actual reaction. The lead ion reacted with your chromate ion to produce what?
Lead, chromium.
Lead chromate. That is your actual reaction. So let me finish. Ionic equation is taking your overall balance equation and breaking up your aqueous into its what?
Initial
Ions,
ions.
right? Spectator ions are you're canceling out the guys that are spectators and they don't do anything in the reaction. They're the same at the beginning as they are at the end. Your net overall ionic equation is going to be taking your spectator ions out and actually showing what your reaction is. We are done. Questions?
Works for me.
Why is it